Let's find the derivative of x cubed plus 4x times y. We have a product rule there. First factor is 4x, second factor is y, since we have two variables multiplied together. Then we have minus y squared equals 5x plus 2. So I'm going to have to use the product rule here. Since we have two variables multiplied together, I'm going to do the derivative of the first, original second, plus the derivative of the second times the original first. So I'm going to take the derivative of both sides of this equation and only put a dy dx if I've actually taken the derivative of a y term. So first piece, derivative of x cubed is just a regular 3x squared. No derivative of y there, so no dy dx. Derivative of 4x, my first factor, is just 4. No derivative y there, so no dy dx. So derivative of the first gets multiplied with the original second though. Derivative of 4x is 4, original second is y. Now product is always plus. Now I'm going to do the derivative of the second term. Derivative of 1y is 1 dy dx. I'm going to move it at the end. And that's going to be multiplied, that derivative of the second factor will be multiplied with the first factor, 4x. Minus the derivative of y squared is 2y. Since we took the derivative of a y term, we need a dy dx. Equals the derivative of the right side, derivative of 5x plus 2 is 5. I highly recommend checking these derivatives over before you solve for dy dx and then get all the way to the end and realize you missed a plus where it should have been a minus or something like that. So I'm going to go through and check these. Derivative of x cubed is definitely just 3x squared. So I'm good with that term. Next term, derivative of the first, 4x is 4. Original second is y, so that looks good. Product is plus. Now the derivative of the second term, y, is 1 dy dx times the original first is 4x, so that looks good. Derivative of negative y squared is going to be negative 2y. That needs a dy dx since you took a derivative of a y term. So that looks good. And derivative of 5x is 5. Derivative of 2 is 0. So that looks perfect. Now I'm ready to solve for dy dx. I can either keep it on the left or move it to the right. It doesn't matter. For this one, I'm just going to keep the dy dx on the left and move anything that does not have a dy dx over to the right. So when I'm thinking about 3x squared, that does not have a dy dx term. So I'm going to subtract 3x squared from both sides to move it over. Next term is a 4y that does not have a dy dx, so I'm going to subtract 4y to move it over. Next term, I need to keep it, so I'm going to keep it on the left here. 1 times 4x is just going to be 4x. dy dx stays on the left. And then same thing with the next term. I'm going to keep it on the left. I have negative 2y dy dx. Equals, on the right, I have to keep that 5 over there. It does not have a dy dx. And I also subtracted 3x squared and 4y over. Now that the dy dx is on one side, it's not by itself yet. This is where sometimes we feel stuck. I'm going to put a star on this step. I need to factor to get dy dx all by itself. So I'm going to pull out dy dx and multiply it with 4x minus 2y. 4x is multiplied back with the first term and a minus 2y with the second term. Equals, on the right we have 5 minus 3x squared minus 4y. Lastly, we want to get dy dx by itself. Right now it's multiplied with that factor, so we're going to divide both sides by that 4x minus 2y factor. That way we get dy dx equals the 5 minus 3x squared minus 4y. All those terms that did not have a dy dx go on the top, and then we got those dy dx coefficients divided out on the bottom. So there is a pattern to these when you solve. And we would have gotten a different looking answer if we solved dy dx to the right, but they're both equivalent. So lots of good ways to write this answer.